Hi, my name is Scott Leithem and I'm an engineer at Keysight Technologies. Today I'm going to show you an interband carrier aggregated LTE-Advanced signal using our new MXA. The latest 3GPP releases have incorporated carrier aggregation in order to achieve higher data rates and better spectrum utilization. Carrier aggregation is a technique that's used to extend maximum transmission bandwidth up to 100 MHz. Now, up to 5 carriers, known as component carriers, can be used for a single transmission. These carriers can be up to 20 MHz wide, which makes our total bandwidth up to 100 MHz. The carriers can be close in frequency or contiguous, or they might be non-contiguous. In the non-contiguous case, they can occupy either the same band or different frequency bands. The ability to support multiple carriers on different bands is sure to stress the hardware design. Keysight makes the design engineer's life easier by providing intuitive tools to make complex measurements quickly and easily. Now let me show you those tools. We have 2 signal generators here, both Keysight MXGs. One of them is set to generate 2 contiguous component carriers in the 800 MHz band, and the other is set up to generate 3 contiguous component carriers in the 2.1 GHz band. Now I'm using a power combiner to feed the 5 component carriers into the MXA for analysis. As you can see here on the screen, I've set up the analyzer to sweep greater than 1 GHz span. We cannot capture the entire signal within the IF bandwidth of the signal analyzer. Today we're going to be using a single MXA to capture all 5 component carriers sequentially. In order to do the modulation analysis measurement, we're going to enter the LTE-Advanced embedded application. Next, I need to set up the signal. The way I do that is by going into our component carrier dialog. In this case, we've selected 5 component carriers and non-contiguous operation. The offsets and the system bandwidths I've already set up. We also have another tab that allows us to set up some specific test configurations. The 3GPP defines these test configurations for both contiguous and non-contiguous operating modes to test all the base station requirements. These configurations can be tedious to set up, especially with multiple embedded menus and settings. However, with our new N9080C embedded application, we can very quickly set up one of these measurements just by filling in the initial setups and going back to our carrier config presets menu and selecting the particular preset that we want to use. So you can see in our basic results view, we're showing constellation results, spectrum, error vector spectrum, and summary. Now these windows are also completely configurable to show you the results you want to see. With a single tap, I can choose and select what result I want. I can also select what component carrier that I want to set it for, and I can set the format of the results. So in this example, I'm going to choose error vector time. A new feature has actually been added, the flexible measurement mode. Now with a few button pushes, it's possible to configure a custom view that shows exactly what you're looking for. So I'm going to add a window on the top, and you can also see that I can drag and resize the windows as needed if there's a particular measurement that I want to see in more detail. So the only thing I have left to do is make a few taps to add in the measurement result. So in this case, I'm going to choose a frame summary for my result. When testing interband carrier aggregation, EVM and time alignment error between component carriers is important to minimize in order to ensure that the user equipment can properly receive multiple carriers at the same time. This test result is available as one of the result tables. Let's select the time alignment error summary from this list. That's known as the cross carrier summary here. You can see how easy it is to choose cross-carrier summary for one of your result windows. Now that you're finished modifying the setup, you can save a custom view with its own name. So in this case, we're going to just choose the default name. And this makes it very easy to get back to the view and obtain measurement results without the time or effort that's required to set up the measurement again. We did want to show all of these component carriers simultaneously. And the way that we do that is using sequential capture and then performing a single measurement. I've just shown you how to easily set up a complex measurement like the modulation quality of an inter-band carrier aggregated LTE advanced signal using the new Keysight MXA and the embedded app for LTE Advanced. Using the quick setup dialogues and flexible window displays to create custom setups, it's possible to verify and troubleshoot designs faster and easier than ever before. The MXA has the flexibility to quickly adapt to evolving test requirements that are becoming more and more complex. The performance and features of the MXA ensure confidence in both your test results and your investment. To learn more about the embedded application for LTE Advanced and the MXA, please visit the URLs on the screen. Thanks for watching.